Graphing rational functions is going to be the intent of this lesson today. Let's look at first what the form of an equation of a rational function looks like. So let's say we call the rational function f of x. It is going to be composed of a numerator and a denominator value. Let's let the numerator be the polynomial p of x and the denominator the polynomial q of x, where q of x can never be 0. Okay? We never want our denominator values to ever be 0. These are undefined values, right? Okay, so there are certain features that I'm going to have you look into to be able to graph rational functions. So on the left-hand side of this note-taking guide, that is what we're going to do in order to be able to do the graphing on the right-hand side. So let us proceed. First of all, when given an equation in the form of p of x over q of x, the first thing I want you to do is to completely factor the problem, okay? So factor, if at all possible, the entire rational, and then simplify where needed, okay? So now, once you have done that, you can proceed to do the following. The first thing you will look at, and I say first thing, but any of these features, you can find them in any order. But as far as in our note-taking guide, let's address x-intercepts. The first thing is x-intercepts, and these, as a reminder, are the point or points where the graph will cross the x-axis. All right, where the graph crosses the x-axis. Algebraically, how are these found? Well, once you have completely factored this rational function, there will be some remaining factors in the numerator, and those remaining factors are what you are going to focus on when it comes to x-intercepts. I want you to set any remaining numerator factors or factor, maybe one, but factor or factors equal to 0. And then I want you to solve. When you do so, you would have found the x values where the graph is crossing the x-axis. So if you have 2 factors up here, you will have 2 x-intercepts. If you have 1 factor remaining after you have fully simplified, it will have only 1 x-intercept, and so forth. Okay? Vertical asymptotes, they're going to be drawn as vertical lines, not as a solid line. They're going to be drawn with a dashed line that go up and down, and the equation of these lines will always be x equals some number. All right? Now, to find the equation of the vertical asymptote or vertical asymptotes, what you're going to do, similarly like what you did in x-intercepts, but we are going to change this word to denominator. So here we go. You are going to set any remaining denominator factor or factors equal to 0. And once you've done that, solve, and that will give you the vertical asymptote or asymptotes. Okay? Again, however many factors are left in the denominator after you have factored and simplified the entire rational, that's how many vertical asymptotes you will have. Horizontal asymptotes require you to focus on the degree. Okay? The degree. Now, if you have forgotten what the word degree stands for or represents, or the definition, reminder is that it is the highest exponent of your polynomial. Okay, so you would look to your p of x numerator value, look to the highest exponent to find the leading term, and look to the highest exponent to look for the leading term. So you're going to compare the degree of the numerator and the degree of the denominator. When you compare the two numbers, if the number of your numerator, remember p belongs to the numerator and q is the denominator. If the number in the numerator is bigger than the number in the denominator, you are going to inform me that there are no horizontal asymptotes for this particular graph. If the reverse happens, if the degree of the numerator is less than the degree q of the denominator, you are going to draw the y equals 0 dashed line, which in essence is the x-axis. Okay. If the degrees of the numerator and the denominator of the polynomials here and here, if they are both the same number, you're going to do some minimum calculations. You are going to take the LC of p of x and you're going to divide by the LC of q of x. All right, now what do I mean by LC? LC stands for the leading coefficient. And all of these are terms that you learned in the polynomial section. But let's say you have forgotten or you do not recall and need a refresher. So let me remind you what that means. So let's say I gave you a rational function written in this format, and I'm completely just making this up. Okay, now what you would do is, obviously when you proceed to work this out, you're going to factor and whatnot, but right now all I'm focusing is reteaching you guys about degree and leading coefficient. Okay, so if you look at this p of x, the degree of this p of x polynomial is the highest exponent. The highest exponent is right here. Okay, so this right here is my leading term. The degree is a 3. Keep that in mind. If I look at the polynomial q of x downstairs, I look for the highest exponent. It's right here. Therefore, my leading term is this one. The degree is 3. That's what I identified it as. Since the degrees are the same, which this is what this implies right here, what I'm going to do is take the leading coefficient upstairs. The leading coefficient is this number, and I'm going to divide it by the leading coefficient of this leading term, which is this number. So my horizontal asymptote will be y equals leading coefficient upstairs divided by leading coefficient downstairs, which reduces to y equals 1/3. That's what this process means. Leading coefficient of the upstairs value divided by the leading coefficient of the downstairs value. So it requires you identifying the leading term, and the leading term is identified by finding the highest exponent of all terms of the polynomial. Okay? So that's how you do horizontal asymptotes. Last but not least feature is holes. The holes are breaks in the graph. Okay, and the breaks in these graphs are usually denoted by an open circle for the coordinates of x and y of that invisible point, so to speak, We do not fill it in like we do with regular coordinates of a point because this point is not part of the graph. It's not included, okay? So, how do we find holes? Well, the question I need you to ask yourself is the following. Were there any common factors or singular that canceled? Okay. If no factors were canceled, you would tell me there aren't any holes. If you answer yes, then you will proceed to set the common factor. So whatever factor got canceled, I need you to set the common factor equal to 0 and solve. Okay? That will then give you the x-coordinate of the hole. Okay? That will give you the x-coordinate. You will then use the x-coordinate to find the y. And the way you will do it is whatever you solved for, take that answer. Now substitute the x value you found. Take the x value and substitute it into simplified rational equation. And you will solve it for y. And once you do so, you will have an x and y coordinate that you can plot. So that's a lot of writing, but you will see that in the right-hand side of this note-taking guide, I will show you exactly what that looks like. So let's proceed to example number 1. Remember, the first step I told you was to factor first before doing any sort of graphing. Notice that upstairs this is a difference of squares example. So x squared minus 9 can be factored as x plus 3x minus 3. Downstairs x plus 2 is as simple as that can get. So if you look at this, there is nothing here in this rational that can be simplified any further. There are no common factors, so we are actually done, okay? Next step, use this factored answer to start finding all the attributes, okay? So let's go first with x-intercept. X-intercept says, if we move it over here to the left, says that you are supposed to take any remaining numerator factors and set them equal to 0. My remaining numerator factors are both of these, all right? So in solving for x-intercepts, I take the remaining factor x plus 3, set it equal to 0, and I take the x minus 3 and set it equal to 0. Solve, subtract 3 on both sides. Here I need to add 3 on both sides. So my x-intercepts are -3 and 3, or plus minus 3, whatever way you want to write it. So I'm going to come over here, dot at 3, dot at -3, because -3 and 3 are your x-intercepts. These are the points where the graph crosses the x-axis. Next, let's find the vertical asymptote. Vertical asymptote says to take any of the remaining denominator factors and set it equal to 0. All right, so let us do, wow, that was a really poorly drawn line. Let's try that again. And there we go. Let's start with vertical asymptotes. Vertical asymptote says to take your remaining denominator, set it equal to 0. I'm going to solve by subtracting 2 on both sides, and I get x to be -2. So set equal to 0, solve. Now I will draw that vertical asymptote at x equals -2. Go to -2 and draw a vertical line that goes through the x-axis at -2. It will be a dashed line. VA labeling it there just to remind us. Horizontal asymptote, reminder what that entails. Horizontal asymptote tells us to go look for the degree of the polynomial both in the numerator and the denominator. So let's go do that. Let's compare. So the degree highest exponent in the numerator was a 2. The degree in the denominator was an invisible 1, because that's x to the 1. 2 is larger than 1. I come over here. P is the numerator. That one is definitely larger than 1. It tells us then that there are no horizontal asymptotes. Okay? So the degree of my polynomial P was a 2. The degree of my polynomial Q was a 1. 2 is greater than 1. No horizontal. So I'm going to come over here and write none. There aren't any horizontal asymptotes. Holes. Let's take care of holes. Holes, let's shift over again. Were there any common factors that were canceled? The answer is no. We didn't cancel any common factors. It was all able to be factored, but there were no common factors. So here I'm going to write none. And if you want to remind yourself why you said none, you could tell yourself no common factors in your notes so that you remember why you said so. Okay, nothing canceled. Okay. When graphing, even though the features on the left did not stipulate, y-intercept is a powerful tool to help with graphing. So we are going to make sure we do it. By letting x be 0, you will always be able to find the y-intercept. Why? Because the y-intercept is the point on the y-axis where the graph crosses. So x is always going to be 0. So if I substitute 0 here or here, whichever one, does not matter, f of 0 would be 0 squared minus 9, which just gives me -9. 0 squared is 0, and 0 plus, that's a 0 to the first power. 0 to the first power is 0 plus 2 is just 2. Our y-intercept is going to be -4.5. So 1, 2, 3, 4.5. And what you would do is you would continue substituting x values to come up with some more points. But in your Delta Math that you will be working on with today, you will just hit graph and it's going to populate the curve for you. So you can just follow suit here on an approximate graph of what it's going to look like. So here's what it will sort of look like. Okay. All right, let's go and do this last one. Let's go down here. Again, the first step you will always do is factor. This is a trinomial where a is a +1. So let's ask ourselves the question, what two numbers multiply to be -5 that at the same time add to be -4? Well, I'm going to put my x here because x times x is x squared. What combination multiply to be -5 that added to be -4? Turns out it is a -5 times a +1 will give me a -5 and combine to give me a -4. This is a difference of squares. X squared minus 1 is a difference of squares. So x minus 1 and x plus 1. Difference of squares looks just like the one up here of x squared minus 9. Okay? All right, so are there any common factors to further simplify? Yes. So x minus 5 over x minus 1 is our rational that we are going to focus on. So let's go do our x-intercepts. X-intercepts, look to the left of your screen, says to look for numerator factors and set them equal to 0. If I set x minus 5 equal to 0 and solve, my x-intercept would be 5. 1, 2, 3, 4, 5. Vertical asymptote tells me to look at the denominator. The denominator, set it equal to 0 and solve. That leaves me with an x equals to 1 vertical line. So I'm going to draw a vertical line at x equals to 1. This is my vertical asymptote. Okay. Horizontal asymptote tells me to look at the degree of the numerator polynomial and compare it to the degree of the denominator polynomial. The degree in the numerator was a 2, and the degree in the denominator was also a 2. So shifting over here, we see that if the degrees are equal to one another, you are going to take the leading coefficients and divide. So let's look at what the leading coefficients are. The leading coefficient of my numerator is the number in front of x squared. That number is a invisible 1. The coefficient of the x squared downstairs is also a 1. These are the leading terms right here. Leading term, leading term. So for horizontal asymptote, I take the coefficient from upstairs divided by the coefficient downstairs, and y is 1. So let's put y equals to 1. That's my HA, horizontal asymptote. All right, almost there. Let's do the holes. The holes asked, are there any factors that were canceled? And yes, we did have a canceled factor of x plus 1. So you write down the factor or factors that were canceled. In this case, we only had one pair. Set them equal to 0 and solve. So I found the x coordinate. So I'm going to come over here. -1 is my x coordinate. Now I'm going to find the y coordinate. To find the y coordinate, you take the function and you substitute -1 for every x. So f of x is x minus 5 over x minus 1. Replace -1 here and here. So -1 minus 5, -1 minus 1, and that gives us -6 over -2, which reduces to 3. And that is your y coordinate. So -1 comma 3. So I'm going to come over here to -1 up 3, and instead of a filled in dot, I put a hole. That's an open circle. Okay? So to the left 1 and up 1, 2, 3. Let's find the y-intercept. Remember, y-intercept is just letting x be 0. So f of 0 would be 0 minus 5 and 0 minus 1 is -1, and it simplifies to 5. So 0, comma, 1, 2, 3, 4, 5. Here's my y-intercept. So again, you will connect the dots. Again, in Delta Math, it will sketch the curve for you. If you're doing this by hand in the future, you just keep substituting x values to create more points so that you determine more so what the curve will look like. And that's it. That's your lesson on graphing rational functions.